Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So Schrodinger's 3D wave equation can be solved to give three quantum numbers for one electron atoms. So the wave function, N, L, and M, is a solution with quantum numbers N, L, and ML, and this is called an orbital. So I'm going to go through each of these quantum numbers now and tell you what each of them mean and represent. So the first one is the principal quantum number. And it's given the sign N. And this determines energy, or basically the size of the orbital. And N is also called a shell. But to fully describe the shape and orientation of a wave function, you need two more quantum numbers. So the next one is L, or the angular momentum. Quantum number, which I'm just going to write as Qn. And this is given the value of L, so the one that I showed right here. And this determines the shape. So L can range from 0, 1, 2, and 3. And each of these correspond to different orbitals that we just talked about. So when L equals 0, that represents an s orbital. When L equals 1, it represents a p orbital. And when it's 2, it's a d orbital. And finally, F is when it's L equals 3. And so the values of L can be written as L equals 0, 1, 2, all the way up to n minus 1. And each L is called a subshell. So we had N is the shell, and then L is the subshell. Third, we need the magnetic quantum number. And this is given the value of M with a little l. And this labels different orbitals of a subshell with values to give orientation. So ML is given as L, L minus 1, and finally minus L. And so to give an example, if you look at the p orbital, a p orbital has L equals 1. So the ML values would be 1, 1 minus 1 is 0, and negative 1. And these are all the possible orientations that the p orbital could have. And so these three quantum numbers specify an orbital. And that's why I showed this diagram right here, where let's look at the 1s orbital that we talked about before. The principal quantum number n is 1, which gives you the shell. L is 0 because this is an s orbital, it's circular, right? And then ML is the plus and minus of L, and so it's just 0. So for the 2s, the same thing, n equals 2, but the value of L and ML is the same. But now when we move on to the 2p orbital, n is equal to 2, but now L is equal to 1, because it's the p orbital right here. And so as I showed you for the magnetic orientation, we have 1, 0, and negative 1. And these just show the different arbitrary assignments of which orientation the p orbital is adopting, whether it's pz, whether it's px, or whether it's py. Finally, if I can fit it in a little box right here, we have a fourth thing. Since electrons can be spin up or spin down, we need a fourth quantum number called spin. Magnetic quantum number. And so this is given the sign ms, and this is always plus 1/2, which is spin up, or it is minus 1/2, which is spin down. And this completely specifies in what orbital an electron is and its spin state. And so an electron can be up or down. So using these quantum numbers, n, l, ml, and ms, we can basically specify any one electron atom.